We now reached the final section in the 2004 event, which is the International Award for Innovations in Powder Metallurgy. This category always attracts many strong entries. Indeed, Pacific Sintered Metals of Los Angeles, USA have for the second year been rated as highly commended, in this case for their entry of an automotive gearshift counterweight. However, the verdict of the judges was that the winner in this keenly contested category should be Hitachi Powdered Metals Company of Chiba, Japan, and their customer Denso Corporation of Aichi, Japan, for their entry of an inner hub pulley. Designed for use within a vehicle air conditioning compressor, its function is to act as a mechanical fuse to protect the pulley and belt in the event of overload. In recent years, there has been a growing global demand for vehicles to have variable displacement air conditioning compressors. These compressors offer improved fuel efficiency, reduced power requirements, and increased acceleration performance. They also offer reduced shock loads on engagement and disengagement over electromagnetic clutches. In this type of compressor, it is essential to protect the engine belt from compressor overload. It is for this key requirement that the development of a component with mechanical fuse function was undertaken. Under normal conditions, the product transfers engine rotation to the compressor shaft through the pulley. When the design load is exceeded, the product disconnects the compressor from the engine by breaking itself as a mechanical fuse. This product therefore requires enough fatigue strength to ensure that it will transmit power without breaking under normal conditions, and a relatively lower static strength to break quickly at the fuse portion in response to compressor overload. Thus, the developed material needs to have a high fatigue limit ratio, that is, fatigue to tensile strength. Hitachi worked closely with their customer Denso Corporation to optimize the strength properties of the mechanical fuse. Alloy composition, microstructure and configuration were all critical factors in developing a product that could meet the demanding mechanical and fatigue properties required. The use of a specially mixed segregation-free powder helps to achieve uniform density. The component is produced by a multi-step compacting technique at around 300 megapascals. Compaction is achieved using an integrated punch with core rod, thus decreasing burrs. Sintering is followed by steam treatment, machining and rust prevention treatment. These are the specifications of the product. Powder metal products are generally specified with only lower strength limits as functional requirements. However, for mechanical fuse applications, both lower limit of fatigue strength and upper limit of static strength are needed, and these must be strictly controlled. By optimizing material, process and design, products meeting the requirements of the application have been developed for mass production. In a comparison between PM mechanical fuse products and a conventional electromagnetic clutch, pulley diameter is reduced by 10%, length by 35%, and weight by some 73%. Annual production volume in 2003 was 2.6 million pieces. The product, as utilized by Denso Corporation, is the first such system worldwide to use PM products as mechanical fuses. This development may be extended to new applications requiring a mechanical fuse. This is a classic example of how complex and demanding components can be improved using PM materials and process technology. And thus Hitachi Powdered Metals Co. and Denso Corporation are worthy winners of the EPMA 2004 International Powder Metallurgy Awards.